Abhigna means curious to learn. Today we are going to read units and measurements topic. Actually, it's class 11 physics. So actually my English is very worst. If you get any problem, please you can leave. There is no pressure to you. So it's completely a free a service course. Okay. So units and measurements. Now we are going to deal this topic with basics along with some concepts also by step. Now let's move it. Before diving into the topic, let's discuss some very little things. Actually, we use lots of measurements in our daily life. So those measurements like for time we use the minutes, the hours, some kind of units. For length we use the measurements like meters and kilometers like that. And for the mass, that means for weight we use grams. At the same time we use kilograms also. And for the weight also we use same, for the weight also we use the same gram and kg. So there is a slight difference about mass and weight. In the latter parts you may learn it very quickly and very fastly with very clarity. Okay. And at the same time we use the measurements for currency also. So for currency we use the measurements like 2 rupees, 3 rupees, 4 rupees, 5 rupees, 10 rupees, 20 rupees, something like that. Now I want to introduce another topic, that means physical quantity. So what is meant by physical quantity? This is the biggest question. So I will explain it to very simple answers. Okay. Actually the physical quantities involves the major thing, laws of physics. Yes, first one, it must be followed laws of physics. Point one. At the same time the physical quantities must be measured either directly or indirectly. This is the definition. So for physical quantity, so now apply the same concept to the these physical quantities. Actually these are the some physical quantities. For time we use time 10 seconds. Okay, 10 seconds, 20 seconds, like that. For the length we use 5 meters, 10 meters, like that. So it can be measured directly or indirectly, whatever it may be. For mass also we use 20 kg, 30 kg. But here the important thing is whether these all are comes under physical quantities or not. This is the biggest question. Actually all time, length, mass, weight, all are comes under the simply the definition of physical quantities. But here currency doesn't come under the physical quantities, because the main reason behind it was it does not apply laws of physics. Yes, laws of physics are not applied for the currency. So it is just a measurement. It does not apply any physical laws, any physical Newton third law, Newton first law, whatever it may be, Boltzmann constant, light constant, whatever it may be. It is just a piece of paper. We measure it like a counting. That's why it's called as currency. So the physical quantities must be involved with laws of physics. This is the first point, and it can be measured directly or indirectly, whatever it may be. So the physical quantities definition is completed. At the same time we can derive something from this physical quantity concept. Actually the physical quantity is equals to magnitude into unit. So this is the thing, magnitude into unit. Yes. So here you can clearly observe the things. For time you observe the measurements like that, 5 seconds. For weight you can observe that 50 grams. For length you can clearly measure 10 meters. So here all the things you clearly mentions the magnitude, how much magnitude it was, 5, 50, 10. Simply it's a measurement. Magnitude means measurement into, we also introduced here unit, seconds, grams, and at the same time meters, like that. So physical quantities all are expressed with magnitude along with unit also. This is the physical quantity. So finally we can derive the concept like that. For physical quantity we can, whether it is physical quantity or not, we can decide with this, just with 3 simple rules. 1, it must apply laws of physics. Point 1. At the same time its measurement either in direct or indirect, no problem. At the same time the physical quantities, all physical quantities expressed with like magnitude into unit. Okay, this is the things about the physical quantity. Now I have another question, so let's dive into the another topic. I want to know which unit you use in your life. Okay, which unit you use in your life for road, for a long road. What is the quantity, what kind of physical quantity you use, what kind of units you use. Okay, just focus on the unit, not the physical units, physical quantities. Actually, what units you use for the long road? Yes, it obviously either kilometer or mile. Point one, clarity. Example, a small boy with some height. What unit you use? Either feet, he is some 5 feet, some 5.5 feet, or some inches, or some centimeters. These are these kind of units you use often. At the same time, you it's some virus. Okay, it's some virus, and it's some bacteria. So what kind of units you use for virus and for bacteria? These kind of some nanometers. Okay, so for the sake of length, for the quantity, for the physical quantity like length, you use different kinds of units. Either you use kilometers, you use feet, you use inches, you use centimeters, you use nanometers also. So there are several units for the single thing. This is clearly visible from this exercise. Nowadays it is actually not a big task, but in the past days the scientists literally they shocked and they surprised about this thing. So what units we have to use for our regular use throughout the world, which unit must be used? They made several discussions and they derived some kind of measurement systems. So different unit systems they introduced. So for the each time, for the different situations, each type of system gets popularized. Like our heroes, some days some talpati hero in different form, in his highest form. Okay, in some days some Rajnikant gets highest paid and gets highest form and gets highest popularity in that phase. So in different phase each hero gets different kind of popularity and he may be the kingmaker for that industry. So at the same time the different unit systems also in that time, in that good days, they are the leaders for the world. So I will introduce some kind of different systems, different unit systems. So the first unit system is CGS. Actually you know this system, actually C means centimeter, C means centimeter, G means literally it's mass, gram. At the same time S means obviously you know time, seconds. So this is the measurement, actually this is the unit system. Okay, and there is different kind of unit system I will introduce. Actually in the second case, FES unit system. So you also know it, actually F means foot, FOT foot, and at the same time P means pound for weight. Okay, so for weight that means this is weight means mass, for mass. At the same time, this is length, length with a different indication, some length. Okay, so different. For length they use foot, for the mass they use pound. At the same time for the time they use seconds. So this is FPS system. This survives a several years in the later part of in the past days of science and technology days. Actually if now the third system, MKS system. So MKS system, so here length they measures in meters. Okay, they measures in meters. For grams they measures in kg, and at the same time time means seconds. So no, not changed much. Okay, this is the MKS system and this is the most popular system at that times. Okay, but the real hero comes now, actually with some kind of updates, some kind of version 2.0, some kind of version 3.0. Actually here the major units are 3, 1 2 3. Here also in the past time also the major units are in 3 forms only. But the our hero with so much version 2.0 updated version, it comes with a name called SI unit, System of International. Nowadays it is the most popular thing, and nowadays the most of the scientists use System of International system. For the kilometers it's km. Okay, for the meters, so in the System of International for the length they use meters, and for the mass they use kg, and for the time they use seconds. So sir, what is the difference between previous one and this one? Actually the previous MKS system and now SI system. What's the difference? I cannot find any much difference. So this is your question. Actually, it is an updated version, not with 3 units. It's come with totally 7 units. Along with these three, there is another 4 also. So this is the system of international system comes in this world. Okay. So is there any problem to use CGS system, FES system, MKS system, SAS system? No problem. Actually, but scientists used it SI system very much for the uniformity thing. Okay, so this is SI unit. In the latter part of this lesson, for this lesson, I will introduce those different kind of extra 4 measurements. Those 4 I will introduce those units, not measurements. Okay, I will introduce those units now. Actually, the first one is actually 1 2 3 completed. The fourth one is actually for current. So for current they use ampere. Okay, for current they use ampere as a international system. Okay, in international system. For temperature they use Kelvin, but in our days and in the most of the situations in Indian system we use centigrade, 10 degrees centigrade, 30 degrees centigrade, and for thermometers some kind of thermometers use Fahrenheit, but they use in the system of international system they use Kelvin as a major unit. Okay, and at the same time for the molecular things, they use the unit of mole, so mole units like that. And at the same time for the luminous, for the brightness, we can measure it with the units called candela. Okay, candela. So okay, I will introduce some another thing. For the sound you can measure it with units like decibels, 50 decibels, 30 decibels, like that. Same for that light also we use 50 candles, 30 candles, like that, candela, like that. Okay, these are the different kind of unit systems which are used in the past, but nowadays the hero is the kingmaker is SI unit. Okay, system of international system. There is just 7 fundamental physical quantities, physical units. There are fundamental most used units. Actually, you clearly notice that I several times emphasize on the thing fundamental units, fundamental units, fundamental units. Why I am emphasizing that thing mostly? Actually, there is a different term for that also. Actually, those term is called, one is fundamental unit. Okay, one is fundamental unit, and the second unit is derived unit. Okay, sir, what is the difference between fundamental unit and derived unit? Is there any big difference? Yes, there is a big difference there. Actually, so in color theory, the primary colors are red, green, blue. These are the primary colors. So with using these primary colors we can produce n number of colors. Example, for red, green we use some different color, for different color and different color. In these conditions we can produce at least 8 kind of colors. With those 8 kind of colors we can produce 36 colors. With that 36 colors we can produce like this cycle goes like going. Actually, okay, so same condition. Actually, for the units also we use those units. Actually, we use only 7 fundamental units which cannot bisect, which cannot be resolved into further units. Actually, these are the first units and these are the last units. For the reverse, actually for the forward we can produce n number of units. We can derive different kind of units. Actually, different kind of physical quantities can be expressed with these kind of fundamental units. So I will write some kind of derived units for you. So I will derive. Before deriving, I will introduce those fundamental units of the SI units. Actually, they are 1 mass, meter, kg, second, ampere, Kelvin, mole, candela. With these 7 fundamental units we can produce n number of things. Example, for area. So what is the unit for area? We often use the area as meter square. Okay, 10 meter square, 30 meter square. How it is coming? Actually, how this unit meter square is coming? Actually, there is a theory, not theory, there is a concept from using these fundamental units. Actually, the area of the problem, okay, area formula is area formula is L into B for any rectangle like that. Okay, so L, here length means L is in length. Okay, L is in length measured in meters. At the same time breadth is also measured in meters. So meter into meter square. This is the thing how the area measurement, like area's measurement meter square, is derived from the thing here. Okay, from the fundamental unit like meter and meter. So these fundamental units helps to produce another derived units for area. At the same time we can take another derived unit for density. Actually density, okay, density we often use the units like 10 kg per meter cube. This is the measurement we use. How the kg per meter cube unit comes? Actually it comes from the derived unit. I will show the formula. Actually the formula for density is mass by volume. Okay, mass by volume. Okay, mass by volume. Okay, the mass can be measured in kg or grams, whatever it may be. So kg or grams, but in SI unit we use the fundamental unit for mass is kg. So kg, upper part is kg, so kg is clarified. How meter cube come? Actually the formula volume for any cube like that, cube formula is m into m. So how it is come? L into B into H. Okay, L into B into H. Length can be measured with meter and breadth can be measured with meter, and at the same time height can be measured with meter and upper part is. So here kg by meter cube, the unit comes like this. So this can be derived from the fundamental unit like kg, at the same time meter. With these two fundamental units we produce the kg meter cube as a different derived unit for density. So this is the process. So you can clearly notice that fundamental units are, actually these fundamental units means units which can neither be derived from another, not can they further be resolved into any other units. Okay, this is the fundamental unit. What about derived unit? Units of the physical quantities which can be expressed in terms of different fundamental units. Okay, it can be expressed with different fundamental units. This is the difference. Okay, in the latter part of the lesson you may come across the different kinds of physical quantities and different kinds of units. Okay, either it may be derived units, not fundamental units, completely derived units. You can find a lot. Okay, we are going to derive another last one. Okay, last one, acceleration. Actually acceleration formula is rate of change of velocity. So v is a different velocity and u is a different velocity. This is the last velocity, this is the initial velocity, and the difference in the velocity divided by time. Okay, for the velocity we measured with like meter per second. Okay, this is the meter. So this is the formula for velocity, and this is also another velocity. U means initial velocity. So initial velocity. So and time measured in second. Sir, what is initial velocity, what is final velocity? I cannot understand, please explain more deeply. Okay, I will introduce. Actually a bike starts from your village to Chennai. Okay, so in Chennai actually your bike starts with how much velocity? Starting 0. Okay, with 0, but at last it reaches some 100 kilometers. So this is the main. Okay, initial velocity 0 and at the same time final velocity 100, like that. Okay, so there is another bullet. Okay, so okay, this is the bullet. Actually this bullet starts, okay, this bullet starts going, okay, from the gun actually, and there is a tree. Okay, there is a tree. So this bullet starts and gets coming from the gun. Okay, what is the initial velocity? U, some 90 kilometers per hour or 110 kilometers per hour, depends upon the bullet speed, depends upon the gun quality. And what is the final velocity? V means what is the final velocity? 0. So if it is, whenever it meets the tree, it just gets stopped. Okay, this is the difference. Okay, this is the final velocity, this is the initial velocity, this is the difference. Okay, so you can get the clarity. If you don't understand, just revise it. Okay, once again. Okay, so for velocity, the formula for velocity is meter per second. Okay, this much of meters within this seconds. Okay, now the important thing comes here. What is m by s minus m by s? Is it 0? No, it's not 0. Okay, it's not 0. So if you go through its final velocity 4 something, so its initial velocity something 3, so the answer must be comes like 1 meter per second. Yes, with 4 meters per second, this is, and this is the 3 meters per second, and answers also comes within the units like meter per second. So this is meter per second. At the same time, in the denominator we get the concept like, yes, so meter per second. Now what is the final answer? Meter per second by 1 by s is equals to meter by second square. So this is the acceleration formula. Acceleration unit is meter per second square. Meter per second square. So if you introduce any question, if you find any question with the acceleration, you can find the 10 meter per second square, 20 meter per second square, and 0.6 meter per second square. You can notice these kind of answers. Okay, meter per second square, meter per second square, meter per second square. This is the point. Okay, so you derive, you come across the different things. You first to know the units. You first knows the units, then you find the difference between different kind of units like international system of international system, mks, fes, cms, like that. Then after, you come across the what is the difference between fundamental units and derived units. Now the important thing, most of the times it asks in the exams. Okay, so is there any difference, is there any conversions from one unit to another unit? Okay, is there any conversions from one unit to another unit? This is the biggest question. For the sake of length, you can find millimeter, at the same time centimeter, at the same time decimeter, at the same time meter, at the same decameter, at the same time hectometer, at the same time final kilometer. So if you multiply with 10 10 10 10 10 10 10 10, you find the different kinds of units. So I'm asking the question, is there any possibility to change the units from one unit to another unit? Yes, there is a clear possibility to convert the units from one unit to another unit. So I will show the different kinds of units for you. So 1 kilometer is equals to dash meters, it's 1000 meters. So this is the conversion. 1 kilometer can be converted into 1000 meters. Okay, this is the conversion. Next, another thing, 1 kg is equals to how many grams? It's 1000 grams. Okay, this is the simple conversion. I will show an indifferent and different kind of conversions to you. Actually, now let's move that. 1 centimeter is equal to how many meters? This is the question. Actually, we know, we come across the different things. 100 centimeters is equals to 1 meter. Okay, 100 centimeters equals to 1 meter. Then what is the question about? What is 1 centimeter is equals to 1 dash meters? Okay, 1 centimeter is equals to how many meters? This is the question. Actually, 100 equals to 1 meter. Then 1 meter, then 1 centimeter is equals to how many? This is means x. So x equals to, then question like this, x equals to this, x goes like this. Okay, 1 into 1, 1 into 1. At the same time, this comes under the division. So answer 1 into 1 by 100, 1 by 100. So answer is 1 by 100. So this is the answer. Okay, 100 centimeters is equals to 1 meter. Then 1 centimeter is equals to how many? So this comes under like this. Okay, so I will explain again. 100 centimeters is equals to 1 meter. Then 1 centimeter is equals to how many? Then the x will be, x goes like this, and 100 comes like this. So this is the transplantation, and at the same time 1 into 1. So 1 into 1, final answer is 1 by 100. So this is the difference. Okay, this can be further simplified like this. 1 by 100 can be further 1 by 100. Okay, 1 centimeter is equals to 1 by 100 meter. Okay, this can be further simplified like this, 10 power of minus 2 meters. 1 centimeter is equals to 10 power of minus 2 meters. This is the final answer. This can be possible. Okay, so I give the task to you. I'm giving the task to you. 1 meter, converts it into meters. okay, and 1 micrometer converts it into meter, and 1 nanometer converts it into meter. Okay, this is the question to you. So will you do? I think a slight difficult to you, I think. Okay, so I will make the thing for you easy. Okay, 1 millimeter is equal to 1 by 1000. So the final answer will be 10 power of minus 3 meters. 1 millimeter for 1 micrometer means 1 by 6 zeros, that means 10 power of minus 6 meters, and 1 nanometer is equal to 1 by 9 zeros. Okay, 1 by total 9 zeros, that means 10 power of minus 9 meters. So this is the silly answers. Okay, this is the conversion for you. So this is the conversion for you. And I have another question to you. 1 kilometer converts into millimeter. Okay, how many millimeters? 1 kilometer, how many millimeters? This is the question. I will solve this for you. Actually 1 kilometer is equal to how many meters? Okay, 1 kilometer is equals to actually 10 cube meters, that means 1000 meters. Okay, 1000 meters. Okay, for 1000 keep it aside, into 1 meter is equals to how many millimeters? It's 1000 millimeters. Okay, 1000 millimeters. So this is 1000 meters. 10 power of 3 into 10 power of 3 mm. So 10 power of 3 plus 3 is equals to millimeters into millimeters. So 10 power of 6 millimeters. This is the final answer for 1 kilometer. So very simple answers. Just use your mind and use your logic. You can find the answers very easily. So nothing hard in it. So this is the fast one for units and measurements. So in this class we use the things we discussed about what is units. Point 1, what is fundamental units, what is derived units, what is the system of international, what kind of international systems uses different kind of measurements and unit system. Okay, this is the topic. And at the same time, last point, unit of conversion, unit of conversions we did. So this is enough for today's class.